Greetings and welcome, friends. Mr. Waddy here, 2.1 Big Ideas Algebra 1 textbook. We are in a new chapter where we're talking about solving inequalities. That's right. Sadly, we're not working on the matters of justice today. We're not, fighting for those who lack fairness and equality. We're just solving inequalities. Um, Sorry, Bruce Wayne, but we're not going to be doing any vigilante justice today. So let's see. An inequality is a mathematical sentence that compares expressions. So far, our only comparison we've been talking about is equality, when two things are the same. An inequality contains the symbol, this is a less than symbol, right there, less than, greater than symbol. Now those symbols, you're gonna have to kind of memorize which one's which, because you don't want to accidentally, that's easy to forget, because they look the same, they're just mirror images of each other. I've got the less than or equal to symbol, or the greater than or equal to symbol. To write an inequality, look for the following phrases to determine what inequality symbol to use. So these key phrases here will help you kind of, if we're translating a word problem into a math problem, these would be kind of the phrases that I'm looking for. Now, one of the things that if I had this phrasing, actually, just to make an example of that, if I say 5 less than a number compared to 5 is less than a number, those actually will mean, why do I not writing correctly here, guys? A number. Those will mean different things. Let's see. This first one, 5 less than a number, means 5 is being taken away, 5 less than something. Okay, so x minus 5. Where if I have the phrase 5 is less than a number, this is connected to the less than. Remember when we were translating before, is was our equal sign. You could think about is as being kind of our comparison word, so to speak. So is less than, this would actually be x is less than, the less than symbol, 5. So notice the subtle difference, the only difference between these two sentences is the word is. Okay, so beware of that, my friends. Means something completely different. Okay, so let's see. To write an inequality, you're going to use one of these symbols and be aware of these phrases. Okay, so if I have is fewer than, is less than, I'm going to use the less than symbol. Is greater than or is more than, or you could even add at least, right? At least, right? If I say, the amount of money I spend at Burger King is at least $3, right? I'm referring to a greater than situation. Let's see, less than or equal to, so that's pretty much straight use of it, is at most. Oh, guys, I made a mistake already. Oh, Mr. Waddy, at least would include the number itself, which is why it shows up here. Oh, so sad, Mr. Waddy. That's okay. You guys learn from my mistake. Not bad. Let's see. So less than or equal to is at most. So most suggesting it can include the number, but nothing more than it. Or is no more than is another phrase there. Let's see. And then for the greater than or equal to symbol, you could also have is at least, the one that I just made that classic error on. Oh man, what a blunder. Internet will forever see this. I can't wait for Waddy Math blooper reel to come out the end of 2016. The top 10 best math blunders and bloopers of Mr. Waddy. This will be one of them, I hope. Let's see. And is no less than is another way that I could verbally describe a greater than or equal to situation. So let's do an example here. All right. Let's see. Where's my scroll bar, my slider? All right. So our first example, we are going to be writing inequality. So write each sentence as an inequality. So here we go. We're translating. Let's see if I can notice. Let's just go through and highlight these relational words right here where I'm comparing. So here's is less than. Here is less than, and is greater than or equal. So those are the relational phrases that I'm seeing here. Let's see if you guys and I could translate the rest of this. So for A, it says a number W minus 3.5. I'm going to have W minus 3.5. That's pretty straightforward. Is less than, oh, I just missed it, or equal. So is less than, and then I read the or equal. I'm going to throw that little line underneath there. Classic. To -2. So -2. So that's how I would translate that into a math sentence there, right? An algebraic inequality in this instance. Okay, let's see. 3 is less than. So I'm going to have 3 is less than, so here's my less than symbol, a number n plus 5. So n plus 5. Okay, not too shabby. Forgetting this. Right. I can recognize those relational expressions. Okay, here we go. I like this. C. Okay, 0 is greater than or equal. All right, greater than. I read greater than, so I read a greater than symbol. Or equal, let's put that little half equal sign in there. 2, twice a number. What does the phrase twice a number mean? Yeah, it's multiplication specifically by 2. So this is going to be 2 times a number x, so 2x plus 1. Okay, so that's all right. As long as I kind of spot those phrases and realize, okay, it's going to be a little bit different than, you know, these kind of regular equations that we've dealt with before. Be just dandy. All right, here we go. This is going to be interesting. Oh, wait a minute. Oh dear. Oh dear, guys. My copy. Oh, here we go. All right, all one sentence. I'm just editing my little lesson plan over here right now. And here we go. Wow. All right, so we're not going to just describe inequalities. We're also going to end up solving inequalities. And so far, when we've been solving equations, we've had situations where we've had one solution. We've had infinitely many solutions when it was the case of an identity. And we've had no solution. All right. In the case of inequalities, most frequently, we're going to be in this infinitely many solution case because, but it's not just everything works. It's only numbers that will be greater than or less than or equal to sort of thing, the particular tipping point that I'm referring to. Okay, so here it says, a solution of an inequality is a value that makes the inequality true. All right, so if I said W equals 0 up here, W equals 0 is a solution because if I plug 0 in here, 0 minus 3.5 is -3.5, which is less than or equal to -2. So 0 is a solution, not the only solution for this expression. Or over here, right, I might have n equals 2 is a solution because 2 plus 5 is 7, which is greater than 3. Could I have 0? Is 0 a solution here? Yeah, because 5 is greater than 3. Or phrased the other way, 3 is less than 5. Can I go, do you think some negative numbers would work in this inequality? Let's try -1. Let's get brave here. -1 plus 5 would have been 4, and 3 is less than 4. It works out. How about -2? See, -2 plus 5 is 3. Is 3 less than 3? No, it's so close though, but not less than itself. So, so you can actually see that there will be lots of solutions that work and lots that don't. All right. So any A solution to an inequality is a value that makes the inequality true. All right, so you would kind of determine, check, does it make the inequality true? An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So there's some terminology for us. Okay, so I don't think I was just going to show you some examples, but I think I kind of like just made up some of my own real quick right there that I'm good. Let's see, here it did this little glitch yesterday visually there. All right, so let's get to another example here. Guys, inequalities, these are going to be great. Don't you worry. Let's see, here it says, oh, this is perfect. I'm not even solving yet. It just says tell whether -4 is a solution of the inequality. So I'm doing a check. I would plug -4 in for x. Usually when you substitute in, you want to use parentheses, but in this case, it doesn't matter because the x wasn't being multiplied by anything. So let's see, -4 plus 8 is +4. Is that less than or equal to -3? Sorry, just less than. No, it is not less than -3. So that means -4 is not a solution. Yeah, I plugged -4 in for the variable. Well, let's see. Well, here's the little x. So let's check that out. So here's b. So I'd write -4.5 times, and instead of x, write -4. And is that greater than -21? And here the parentheses did matter because I didn't want this to accidentally look like I was implying -4.5 subtract 4, because I'm not subtracting 4, I'm multiplying by -4. Okay? Let's see. So a negative times a negative is going to be positive. All right, and let's see. 4 times 4 is 16, plus 4 times a half is 2. I get 18. I don't have anyone disagreeing with me yet. I think I got it right. The book agrees with me. Is that a true statement? 18 is greater than -21. In fact, any positive number would have been greater than -21. Just seeing this negative times a negative, I would have been like, that's going to be positive. And even if I was, bad at the arithmetic of multiplying 4.5 times 4, I still could have determined that regardless in this instance. So I could say that -4 is a solution for part B. All right. No es más mal. It's getting this. We're getting this. All right. So let's get to the solving part. Oh, we're gonna be graphing now. All right. I'm just so excited about solving, guys. Solving's like my favorite thing to do. All right. Here we go. Here we go. Got to do some graphing. And fortunately, guys, you guys are so lucky. My graphs are super simple. I'm not looking for anything super accurate or to scale. It's just, yeah, super simple. Let's see. So you don't necessarily have to write this down. So the graph of an inequality shows, all right, Austin, if you don't mind, stop with the ringing, ding-a-ling. So it shows the solution rather than describes it with an expression or relation between two expressions on a number line. An open circle, O, is used when a number is not a solution. A closed circle is used when a number is a solution. An arrow to the left or right shows that it continues in that direction. So guys, for a number line, nombre line, this is what I'm talking about. You draw a line like this. Your number line should probably always have a 0 on it. Possible that maybe you want the 0 on the side, that's fine. And if I wanted, say, 5 to be the value that I'm interested in, that's all you got to do. You don't have to try to evenly space out your tick marks. I'm fine with this, okay? And then if I wanted to represent 5, I mean, we've already graphed. I keep doing that. Oh, yeah. We've already graphed just a single point before on a number line, but this will have things like open circle shaded to the right, sort of. This will actually be a great day to have 2 different color writing utensils. Quests. That'd be good. Good times. So let's see. Let's do this quick little example. Here we go. Graphing inequalities. El más fácil del mundo. Don't worry about it. Don't freak out. So let's see. I'm just going to go through and draw my lines first here. So here I'll have 0. -3 is less than 0, so I'll throw it to the left of it. Ooh, this one I'm going to want to switch around first. This one, 0 is the only point of interest. And well, I guess I can prep the line. I know it's going to be related to 2, so I'm going to have 0 and 2. All right, so that's how I prep my lines here. And now I've just got to graph the solutions. So y is less than or equal to -3. Will that include the point -3? Closed circle or open circle, do you think? Let's see, it's got the equal part here. How did I switch to green? Wow, that was... So at -3, it's going to be shaded in. It's going to be a closed circle because it has the equal to part there. All right, and now less than that, which way should I shade? To the left or to the right, do you think? Well, let's see, less than -3 on a number line. This way are all the values bigger, right? This is the positive axis over here. This is the negative. So I'm going to shade to the left. All right. Hey, it's cool. It's cool. All right. So less than or equal, I would be a closed circle shaded to the left in this instance. Okay. So yeah, that's not that bad. Now this one, I recommend, let's use the sorry, man, I just almost called it reflexive property again. Let's call this the use the symmetric property. This is the same as x, and if I flip this around, it's also going to flip that sign here, okay? So this was a less than sign, now it's going to be a greater than sign. I think that writing the variable on the left-hand side will make it easier for us to graph this. So let's see. So x is greater than 2. Open circle or closed circle? What are you guys' thoughts? Does it include 2 or does it not include 2? Open circle at 2. Right? Because it does not include 2. And let's see, now that I've got it written this way, x is greater than 2. The values that are bigger than 2 are to the right here. Okay? And like I said earlier before the video, I like to think of these as little arrows kind of telling you which way to shade. Right? That's helpful. But that arrow trick only works when the variable's on the left. Because notice if I didn't, right now the arrow would have been telling me to shade it this way, which would have been incorrect. Let's see, does this phrase still make sense? 2 is less than x. So the point 2 is less than everything that counts as a solution. All right, so I just do want to point out that if you were to graph it looking only at this, it does still make sense. Oh dear, I done zoomed out. I got the zoomies. All right, actually, that's what we used to describe our dogs when they would just get pumped and like just start running in circles. Got the zoomies, right? Don't worry, it's not an actual like disease or anything. It's not a veterinarian's concern when they have the zoomies. They're just having a good time, right? And I think, whoa, all right. Whoa, that was craziness. You just saw that again, right? Look at that. We just like broke time and space. All right. Let's see. Before I mess this up any further, x is greater than 0. Does it include 0 or not include 0? Open circle or closed circle? Greater than is not including it, so it's going to be an open circle. and the value is greater than it will be to the right, towards the positive x-axis, if I can call this number line an x-axis. Right, positive numbers are over here, negative numbers are over. All right, we're doing good. We're doing good. Let's see. Let's get finally some solving in here. Oh my goodness. All right. Did we not really hit solving in this example? Guys, wait a minute. Okay. Oh wow. Guys, we're all right. I thought we were like straight up solving today. We're like going slower than that. That's actually good news for us. We can just focus on learning these things. We don't have to worry about solving just yet. Okay. I'm just all pumped about solving. I just want to be like, let's just skip to the next 2 sections. Why not? But all right, we're going to go even slower. Don't worry. It's going to be fine, Internet. We're just writing equations and inequalities rather today. Okay, so here we go. The graph shows the height restrictions in inches h for 2 rides at an amusement park. Write an inequality that represents the height restriction of each ride. So let's see. So ride A, you're only allowed to ride the ride if, let's see, it's apparently 48 inches. That's the same as 4 feet. What's an inequality that describes this? Who gets to ride the ride? The value of h must be what? See, it's shaded to the right. Those are the values bigger than, so h must be greater than. It includes 48. So is this going to have an equal sign or not? Will it have the line or not line? Closed circle here. Thoughts, friends? Well, let's see. Well, I'm writing the equation. This time they gave me the graph. So they gave me a closed circle. That means I need the underline, right? Which is you were interpreting it this way, where yeah, if it didn't have the line, I wouldn't have filled the circle. But since they filled the circle, I done's got to have the line. And let's see. So h is greater than or equal to what number? What number do you think? Yeah, 48. So this is an inequality that describes that graph, which also describes how tall you must be in order to ride that ride. All right? Duh. Let's see. And last problem. All right. So here, 52 is the point of interest here. So h compares to 52. It's shaded to the left. So left is less than, right? These are towards the negative numbers, even though I don't know of anyone who is negative inches in height. That would be weird. But we're going to the left. We're smaller than, so I'm going to do a less than sign. And it's an open circle. So do I need an underline? No. So I'm done. I'm done, friends. This is good stuff. All right. So actually, yeah, today's lesson ended up being el más fácil del mundo. We're just like talking about shading, writing inequalities. So you just kind of have to remember which way is which, and you just got to remember, right, like what these new symbols mean, right? So here's just a quick summary. X is less than 2, less than symbol, open circle shaded to the left. X is greater than 2, open circle shaded to the right, and the symbol is the greater than symbol. And then we've got less than or equal would have included this underline, and the circle is closed, shaded in. And then x is greater than or equal as the underline, so the circle is shaded in. Let's see, and notice that when it's greater than, actually I'll do less than in red. Less than is shaded to the left, right? Less than shaded to the left. And greater than is shaded to the right, so greater than. Right? So You've got like kind of like 4 things to memorize, and they all kind of relate to each other as such. All right, not that bad. Let's see. I'll highlight this red. Bam, there we go. Look at that drawing. That makes so much sense. It makes all the sense in the world. Good stuff. All right, well, thanks for watching Los Amigos de el Internet.